of our sponsors and our speakers and all those types of folks. But I want to thank you, everybody in this room, for coming out and supporting the Energy Summit. And it's not a small deal. I mean, everyone out here has things to be doing. We have faculty members who should be planning courses for their next year. We have physical plant types that are thinking about building maintenance and taking the summer season to get what they can get done. We have design and construction trying to build stuff. We have students here. We have folks the students obviously need to be making money, right? So they can pay for tuition next year. We have a few folks that stand in the front here that actually tending organic gardens. So they need to get back and weed their gardens. So I know it takes a lot of time and effort to get here. And we've come from, I mean, it's just amazing when you think about where we've come from. And we have people from Wilmington, Elizabeth City, all the way to Western Carolina, the whole state. We have big schools, we have little schools, we have publics, we have privates. So it really is quite amazing to have this kind of a group together to talk about a truly transformational initiative that we're working on. In the military, I was in the Navy, and you know, it's the greatest service. Phil Jones will agree with that. Obviously, Avery Levins thought it was the greatest service. But in the military, in the past, we used to fight wars. We had the Army and the Navy, and they kind of do their own things. After World War II, they really came up with this concept called the Unified Command. And that's where they brought everybody together under a joint command, so that everybody would work together towards a single cohesive goal. We didn't have the Navy guys saying, "No, we got to go send ships. I'm sorry, I can't support your landing over here that you want me to do this land. I'm too busy over here sending ships with my airplanes, and the Air Force is too busy bombing somewhere else." So they wanted a cohesive team where everybody worked. And we called that concept one team, one fight. So that everybody's on the same team, they knew the mission, they knew where they were going to go, so they achieved the objective. And I see that in this group right here, is we have people with all sorts of different perspectives. And on that continuum on energy savings, you may be here, you may be here, but we need to all come together, one team, one fight, to think about achieving the goals we need to achieve over the next 10 years or so. And we've said that number $1 billion enough, so I think that's going to be a wonderful thing. All right, what also is amazing is, I don't know about you, but I may seem animated, but I'm very conflicted. That last set of folks, I mean, those kids, I'm intimidated. I really am. Oh my gosh. I mean, when I was in college, I think I ended up the homecoming float committee. and I was a rush chairman of my fraternity. That was about all the accomplishments I've had. To hear about the things that they're doing, it's quite amazing. And I watch the kids on our campus here, the students on our campus, and I'm just amazed every day about what they can accomplish and what they can do. So it was also amazing is that you all sent in these 200 or so slides. You've seen them flashing up here. I don't know if you had the time to look at them. There's a lot there. There's a ton there. Jen sent them to me about a week ago and said, pick out some out of this to talk about and facilitate a best practice workshop. So I'm looking through it. I'm thinking pretty good. Man, we saved 30% energy. We got 50% water savings. You pick a percentage, I'll make it work. But we've done all these great things, and then I start looking through the slideshow, and I get about a quarter way got through it. I'm saying, man, that's really inadequate. There's so many folks out there doing so many great things, and things I hadn't even thought about. So I think that's what's the beauty of bringing this group together, is to exchange some of that information. I mean, we talk a lot of social stuff when we're out here, but I would say when you're in the working groups or when you're out just mingling, try to bring up some neat stuff you're doing and saying, have you thought about, have you tried this? Or here's an idea. Or ask one of your co-workers, I've got a problem, I can't seem to work with you, have ideas. That's where that information exchange is really going to work. So what we're going to do here for the next few minutes, and I know I'm standing between you and lunch, I believe, but maybe one of the presentations you got planned for already for a short one. But we're going to try to get through this quickly. I've just picked out a few items out of that slideshow. And then I'm going to ask the person or a person responsible for that activity that's here today to kind of explain a little bit about that item. And then instead of me sitting here and asking questions and having a panel here, it's kind of like a virtual panel. You're going to be up here in the audience, and if you want to ask a question of that person, there's your opportunity. So if somebody's done something that you think is really cool and would like to try to do something like that, you can ask them a question. Well, how did you do that? I'm just going to facilitate it. You're going to ask the questions. So we're going to give this a try and see how this works out. All right, let me see if I can make technology work as well. Let's see, we should have Brian Pipkin in the audience. Here, stand up, please. We got a microphone. We have a microphone. We hand those guys somewhere here. If not, I'll stand real close to you. You can talk about a lot there. So please, okay, great. Innovate, adapt, and overcome. Make your words on this. Feedback.
Everybody hear me?
Yeah.
Okay.
All right, we're good. I'm Brian Pittman. I'm the English manager for East Carolina University. One of the projects we're real excited about is our boiler blowdown heat exchanger. There should be a picture up there, possibly, so a little magic at me that disappeared.
Click it again. I'm afraid it's good.
There it is. We're real excited about this project for a couple of reasons.
I didn't touch anything.
If you're not familiar with how boilers work, periodically you have to blow them down in order to maintain the dissolved solids, the impurities, and some of the sludge that forms. That's just part of a boiler operation. When you blow down these boilers, you're getting rid of hot water. That's just energy that you have to get rid of, but you're not doing anything with. So what we're able to do was install a heat exchanger, which basically allows us to recapture the energy that we're required to get rid of. So we blow down our boilers, and it actually preheats the makeup water that we put back into the boilers. So this, in essence, allows us to recapture that energy. The other neat thing, too, is because of the pressure and temperature, when we pull this water out, some of it flashes to steam. We capture that steam also as a low-pressure steam, put it back to the plant, and use it for processes as well. So right now, we're on track to recapture about 4,200 MMBTUs of annual savings. We measure this by looking at the temperature difference of both the makeup water going in that's being heated and the temperature of the water that we're draining. Be sure we get the optimal energy transfer. And then we capture that on a daily basis so we can sum up and see that we're actually, achieving the savings that we're projecting. So 4,200 MMBTUs is kind of a hard thing to wrap your mind around, but basically that works out with our boiler efficiency to be about half of the natural gas usage of 1 month on our health sciences campus. So basically we're getting half a month's natural gas that we don't have to burn as a result of this installation of this equipment. The other really neat aspect of this project was it was funded through the energy savings carry forward process. So previous energy conservation measures that we've implemented on campus, the results of the savings that those projects brought about, we applied for, achieved the funding, and we're able to use that to purchase this piece of equipment. And now the savings that this piece of equipment is going to be generated, we'll use to fund additional projects in the future. So it's kind of the snowball effect of energy conservation measures. You do one, you achieve the savings, and it funds the next one that you can do. So this was just a real good success story for us, just all around. Gas rates, our payback is just a little over 4 years, and with the way gas rates, they're historically low now, so I don't see them going up. If they go up, that payback will just decrease over time. So we're real excited about this.
I think that's a wonderful idea. Not all of us, but many of us have big central steam plants. And I haven't even thought about this. We've done a lot of boiler modernization on our campus, and I'm like, holy smokes, how come we haven't seen anything like this? Why haven't we done anything like this? Does anybody have any questions about that up here?
Is this a retrofit or a new installation?
It's a new installation. We had the pipe work in place to be able to hook up to it, and we did a new installation with this, and our operators control through variable orifice plates based off our chemistry. So it's new equipment for us that we're learning how to operate, but so far we've had good success with it.
Another question?
Is it on one new boiler, and what's the size of that boiler?
It's actually sized for our entire main campus boiler steam plant. So we have 4 boilers actually that are hooked to it, and then depending on the number of boilers we have in operation, depends on how much water we put through it. So it's sized anywhere from 1 boiler operation for summertime up to 3 boilers. So we have 1 in standby, 3 boilers in wintertime for winter operations.
Okay, any other questions out
Way
there?
up there.
Pardon me?
Way up there.
Way up in the corner.
What was the cost of the installation?
The cost of the installation between the new heat exchanger, we also replaced some piping that was going to it, installed new piping, was just under $200,000. And then we're estimating with the current gas prices, we're at right around $50,000 in annual savings at the current gas prices. And we estimate those will only go up, so our payback will come down as a result.
All right, any others? That's a pretty impressive thing, 200, the one over there? Okay, I'm sorry.
Is this still in like trial and research
implant it. It's
Yeah.
in operation, you walk down, take a look at it, stick your hands on it. We are looking at our other health science campus to see if we can actually apply the same technology there. There'll be some, some differences, but it's definitely something that can be applied on, any bowler setup.
All right, anyone?
How long does a unit like that last? When will you have to replace it?
It will be periodic maintenance on it from time to time. We conservatively estimate the lifespan of 15 to 20 years on the equipment itself. It can go longer, it can go shorter if we don't perform the maintenance, but periodic maintenance, we anticipate 15 to 20 years out of it. So after 4 years, it's just basically a money maker for us.
Anyone else? All right, so if you have any questions about this technology on your campus, or you're thinking about it, you know who to call. East Carolina University, obviously, is going to be a subject matter expert on that, and that was Brian Pipkin, and I'm sure you give them a call. Bill Bagnell over there at ECU will also point you in the right direction. I'll be calling him later this week.
It's also available on our sustainability website, so if you want to see more pictures or info, you can go to sustain.ecu.edu and all that information is there.
Wonderful. Thanks so much. All right, I try to move slides here, one slide. Okay, the next person I want to call on is Stan Cross from Warren Wilson, one of our privates here, and he's going to here, there he is. He's going to talk about their college eco dorm, the nation's first LEED EV Platinum dormitory. That's not a new construction LEED Platinum dormitory. That's an existing building. So they took an existing building and got a LEED Platinum out of it. So I thought they'd be interested to hear how they did that. Yeah, we want to Thanks, Dan.
Hello, everybody. My role at Warren Wilson College is to direct our Environmental Leadership Center. And when this building came online in 2002, it was way ahead of its time. So LEED had not yet built criteria for dormitories, which is why we went back after the fact to an existing building process. But the real beautiful story from my mind about EcoDorm is that it represents what we've been talking a lot about here so far, which is the engagement of students on campus. We would not have EcoDorm if it wasn't for students on our campus, similar to the ones that we heard speak earlier today, who back in the late 90s and around 2000 got really ticked off that Warren Wilson College wasn't building buildings that reflected our commitment to environmental responsibility and social justice. As a result, those students led a process where we put together a committee that involves some key administrators, staff, and this group of students, and an architect from Asheville who volunteered his time to meet weekly and go through a design process of what would a green dormitory look like for Warren Wilson College and for the needs of the students. The result is this fantastic building that's regarded as one of the highest performing dormitories in the country. And because the students were engaged from the get-go and actually led the process, the criteria for this building, first and foremost, was to create a living laboratory for sustainability, where students could actually experience what it's like to try to live sustainably in an effort to try to build empathy for how difficult it is. Empathy that student leadership could then bring back to the college and understanding how difficult it is for the institution to do it as well. And it's proven to be just that. It's one of our most popular dorms for students to get into. Once they get in, they tend not to leave. And it really does build community, both in terms of living internally with the equipment and being in a building that's really sustainable and trying to live into those values, but also extend it out into the landscape where you can see a permaculture garden that today is about 3 times taller than that, bearing all kinds of fruit from peaches to raspberries and blueberries and vegetables, all kinds of food that then infuse it back into the dorm where students form community around that food and have those discussions about how difficult it is to try to live into one's values.
All right. Do we have any questions? Boy, this is going to be a very popular one. Yes.
I was wondering if you had a class that the students went through as part of the experience of documenting that, designing and documenting, and also if anyone has been able to take their LEED accreditation exam through that process. You could just speak about the documentation.
Sure. As far as courses go, at Warren Wilson College, we're very distinctive in that we have, we're a work college. So every student who goes to Warren Wilson College has to work 15 hours for the institution, which means the students inherently run our college. So students were engaged in this building on the entire construction side of the building. So not through an academic course, but through being on carpentry crew or plumbing crew or electrical crew. They were engaged in the actual construction of the building. The permaculture landscape outside came about by a group of students and staff and faculty coming together and creating an independent study to learn about permaculture. And through that course, they designed the landscape that is part of this building now. As far as folks going on and taking the accreditation exams, we don't have a formal building science or architecture program at Warren Wilson College. But again, through that work program, I know at least one student who was engaged in this process and engaged in the LEED certification ED process, who now works for the U.S. Green Building Council out in California as their communications director out there. So it led to a job for her.
Any other questions out there? Right here, Scotty?
Could you flesh out the two examples of the features of the building, particularly ones that are student interactive?
Sure. Start with composting toilets. They wound up not working. But, so yeah, there's obviously with the LEED Platinum ED certification, there's a lot going on in this building. And some of the features that I think are really exceptional is the rainwater catchment system that we have. We actually have what used to be an old milk rail car that our ex-CFO bought on eBay. Buried underneath the garden, and it collects about 10,000 gallons of stormwater runoff off the roof, and then that's plumbed back in the building to flush all the toilets, and also used outside to irrigate. And we had to go through a lot of work with our code officials to make that happen, and the compromise was that above all the toilets in the dorm has to have a sign that says non-potable water. And so to date, no municipal water has been used for irrigation or toilets in this building. We have a solar thermal system behind the building that heats radiant hydronic floors, both on the first and second floor. We have slabs, tons of recycled content, lots of reused content. We were replacing our farm fences at the time when we built this building, and so we took those oak fences and built them into wainscoting and cabinetry for the building. We also have we used a SIPS panel construction for this building, and we stayed really on top of the folks who were doing the SIPS construction, so the seams were sealed really well. And the result is very little air infiltration for this building. And that combined with the solar thermal heating has this building performing at about, when we look at the EPA portfolio, energy portfolio manager type software, this building scores are 100 on the scale. And it's using about 75% less energy than the three buildings you don't see, which are surrounding it in this quad. And those three buildings also house about 36 students each, but do so using 75% more energy. And you can go to our website, and there's a whole page on EcoDome, you can see all the details.
Okay, one last question here.
Have you ever considered retrofitting an older building?
Every day. Yeah. We have done some retrofits on our campus, doing energy efficiency upgrades on an administrative building and a classroom building, and bringing geothermal heat pump technology in as a renewable heating source for those buildings. So yes, that's something that is critical for us, because just like the state system, we have a lot of old, decrepit infrastructure that we got to deal with. So yeah, it's continually on our mind.
All right, so if you have any questions, you can go to Warren Wilson's website and find more about that. There's another great example of student involvement. How much money did it cost for students to be involved? Nothing, right?
Well, our dean of work is here, he'll argue with you about
Oh, okay. Galley slave driver.
No, it's part of the educational program.
Okay. But that's a great opportunity to talk about getting students involved early to get some understanding of sustainable practices. So that's wonderful. All right, next slide. All right, Chris Smart. This one has kind of caught me. Please help me out. Oh, there it is. Okay. UNC Chapel Hill's Morrison Residence Hall won the EPA's first national building competition. Look at this, by investing less than to avoid more than $200,000 in energy costs. If that's not bang for your buck, I don't know what it is. So I want to find out what the heck that entails. So Chris, you out there?
Up here, Mike.
There you are. Look at you.
Hardest place to get a mic.
That's okay, I'm quick. I'm in good shape.
Thank you, sir. Before I talk about Morrison, I want to give a shout out to you guys, and you guys had a successful energy conservation program before we did, and that angered me. So, congratulations. I think we now are better than you. I don't know if you sure, I'm just trying to make sure that. In all seriousness, you guys have a great program, and you have led us, so good job. Thank you. And so Morrison, we did Morrison a couple of years ago, probably 4 or 5 years ago, right when we were getting real serious about energy conservation. And what we did was probably, I don't know, 4 or 5 things. We had a renovation to Morrison dorm some 4 or 5 years earlier, and we had solar thermal put on the roof. And the solar thermal was the first time we'd done that, it didn't work. So we had the opportunity to say, hey, we're going to gather around and we're going to go optimize the solar thermal system. And here's an excuse, hey, a competition, right? Let's do that. So, bless you. So one of the things that we did was we worked on optimizing the efficiency of our solar thermal capture. We did that by expanding the coverage to include the reheat in the building. Another one of the things we did some LED task lighting upgrades in the general lobby area. That's really, I think, the only place we spent money. We also had a dashboard from the renovation. And you know, the dashboard was a great thing, but when we started to do energy conservation in there, the dashboard was looking at the use of reheat in our buildings, in that building. And the water meters were now no longer, they were out of range. When we lowered the water usage, the reheat water usage in the building, the water meters didn't work anymore. So the dashboard then reported zeros. You know, we get no benefit out of that. So we reworked the dashboard. Lucid Technologies was the one that did the dashboard originally. They were kind enough to work with us to kind of reconfigure what we were showing. We met with the students, and even though it was summertime, we engaged the students to the greatest degree possible, fixed up the dashboard with some of their involvement to try to convey the benefits of what we were doing. So we did lighting, we did solar thermal, we did occupants, education, we did the dashboard, and probably the most effective thing that we did was HVAC controls modification. And that's something that App State is very engaged in. They do a very good job at it. And we have very similar programs in that fundamentally I believe that most of the energy used in a building is through the HVAC system to heat and cool and ventilate. And so the more effectively you do that, the greatest opportunity you have to save energy. And there's a more elaborative write-up on the effort at Morrison on our website, save-energy.unc.edu, so you can see a little bit more of what we did. That $30,000 came to us as a grant from RESPC, and you heard from RESPC earlier. So the students funded the work that we did. And I think we spent about 6 months doing that work, and resulting in phenomenal energy savings. So that's Morrison, I think, in a nutshell.
Any questions about that from the group? Down here front?
We're looking at putting a solar thermal array on a residence hall at UNC Asheville, and we'd like to know what were the kind of things that you ran into in terms of when it first wasn't working.
Okay, you want the dirt, is that what you're saying?
Sure.
Yeah, so we had a thermal storage tank, buried underground tank, that wasn't vented, and that caused the tank to have premature failure. We had a crack in it. We had to vent it, fix the crack. We had no way to modulate load on the thermal storage, on the solar thermal. So we were capturing more than we could use, and still are. And so we had no way to modulate that. And so now, what we started doing actually during the competition was we were dumping heat into the building just to get rid of it, to keep it from getting too hot. And we were cooling it back down. So we had some simultaneous heating and cooling. So the third thing I would tell you that we did, that we've learned is we have supplemental heat for the domestic water provided from the cogen plant, from steam. And that is supposed to operate as a backup system. And we picked the wrong heat exchanger, and it gives us a constant temperature rise. It doesn't modulate that. So if we only need a couple of degrees to get us to where we want to be on the solar thermal system, we'll end up 50 degrees too warm. I mean, these are common sense things that the fundamental problem is we didn't have an owner, somebody dedicated to say, I'm going to take care of this. And we didn't have that normal good review that we usually have on that system. So does that help?
It does.
Okay. Anything?
Last question right here.
Asset evaluation is getting to be a big thing, and this is a really interesting project from my point of view, but from a really dumb perspective, can you tell me what percentage of the overall cooling load was going to reheat?
I can't, off the top of my head. I can tell you that this was one of the first buildings that we applied our HVAC controls tune-up to. And I can tell you that we almost completely eliminated reheat in Morrison, which is phenomenal in this climate. And we have done that subsequently in a variety of buildings. 10 million square feet, we've done that to various degrees of almost completely eliminating reheat. So that sort of gets to your question.
Exactly, my point.
Yeah, okay, absolutely.
All right, again, a great project, minimal amount of money to do it. I like the throwing the gauntlet down. You know, this is all about one team, one fight, but a little bit of sibling rivalry is a great thing.
I do have a secret I want to share. Unrelated. If you promise not to tell anybody. Everybody promise? Yeah. Okay. So, off topic of Morrison, autoclaves. Autoclaves, does anybody have laboratories with autoclaves in them? Yeah, lots of people? Okay, fair number. We just recently found out that the OEM software on the autoclaves has the ability to schedule those off at night with a 5-minute warm-up if you want. We never knew that. Lots of steam usage to keep those things warm at night. So talk to your manufacturer, your autoclaves, get them scheduled off at night. That's a free tip. Secret.
Thank you so much. I feel like we're doing the Price is Right or someone in reverse. Okay, you're right. Okay, next slide, please. Other direction. Other direction. One more. Hey, all right, so this is going to be NC Central, Eric Fraser. That one. Okay, Eric, there he is. Okay, Eric, can talk to us a little about their campus-wide sub-metering system, because as you all know, if you can't measure it, you can't manage it. And so the whole thing, we just talked a little bit about that with the solar thermal, how critical it is to have the information to be able to quantify and justify what you're doing. So over here.
In about 2009, with Duke Energy, we were looking to automate our data collection for our sub-metering system. You know, most of it's manual. We want to be able to track things a lot better than we have. So Duke presented a proposal to us, or a presentation really, about a service that had been approved by the Utility Commission, where they come in and install a system of data collection devices at existing meters, both wireless and wired, and then that information will be collected into a SQL database. And from there, as part of this, they would generate several web pages, really customized to our needs. You know, we constantly update them, display both the real-time information, also kiosk-type software for educational outreach purposes, and database reporting tools where we can go in and query information, find trends, determine costs, and so on. So we went ahead and we implemented that at Central. And so very low cost up front to put it in. We have 47 buildings on campus that are currently on that, and we're expanding it to also measure steam and water on campus. It's very flexible. You know, we really haven't totally utilized it yet. We're finding more and more uses. It's a very powerful tool, very low cost way to get us high class, high quality metering and software installed on your campus facility. So that's kind of it in a nutshell. Any questions?
Any questions? Up here?
Sorry, do you have individual building meters? That's what you're looking at, you don't have like a central campus distribution system?
But we have 2 feeds in from Duke to a central switch gear that's fed through 2 underground loops throughout campus. We also have buildings on campus that are not on that loop. So we're measuring the central feeds that come in. We've installed these initially on all the transformers that feed into these buildings, but also the sub-metering within our newer buildings. We're connected to that as well. So it's a very flexible system. Yes, sir.
So if you're monitoring the individual buildings and the campus as a whole, can you take that technology and narrow it down so specifically to the student?
Yes, well, the tools will allow you to do that. Specifically, the software I mentioned that can be used like for kiosks for display purposes. You can customize the display information any way you like. And that's part of the thing we're looking at with our students and outreach. For example, they have some of them that are pre-canned, but we can go and modify them. In the residence hall, you could display, how much you're using today, or this month. You can drill down as detailed as you want, display it in a way that people can relate to. Like, the money that was spent today to bought, X number of pizzas, or this is the carbon usage for that. It's very flexible. Does that answer your question?
Yes. Now, just a follow-up, if you found that all of a sudden students are spending less than anticipated, would you lower tuition?
That is outside the scope of my job. Is there any question?
Yeah, well, that's a great question, though. We all have to struggle with, and it's always hard because of different colors of money and explaining that tuition pays for the academic side, the state, this is for the state funding. The state money pays the utilities, but I guess it would be reduce our dorm fees. So that's a good way to share it. When I was in the Navy, we privatized all the Marine Corps housing, and what we did is we gave a baseline when you moved into a house, and that's your allotment. If you use more than that energy, you had to write a check, and if you use less than that amount of energy, we got a refund. So,
And one of the 40 tools we have in there is calculating exact cost, say, to the building. And it's very powerful, very flexible.
that's great. Any other questions on a sub-metering program? Oh, right over here.
When you approached Duke Energy, were there any type of grants, utility incentives, or was it just a capital investment on y'all part?
I even hesitate to call it capital investment, very small amounts, like $29,000 to get everything installed. And then there's a monthly charge for each meter. But it's pretty minimal. This is a great service and tool to offer.
So again, another small investment is $30,000 plus a nominal, I'm sure Duke is a nominal fee, and you get a lot of powerful data for that, so that's pretty impressive. All right, no further questions, we'll move on to the next. So now we'll head up to UNC Asheville. It was done, I think they were, Chris was talking a little bit about us being ahead on controls and doing some neat stuff, but I think Asheville actually blazed the trail before anybody on digital controls. So they've done digital controls, 31% reduction in energy uses, implemented in 92. And that's like the Stone Age for this type of stuff. So now, and it's in every campus. So we're going to reach out to, let's see here, is it David Todd? David Todd, where are you? There he is.
You didn't tell me I was supposed to stand up in front of everybody. First thing I want to do is give credit to a gentleman that worked for us named Norm Richards, who started the system in 1992 and really implemented it across our campus. And Norm retired just a few months ago, so we're kind of starting a new era with what we're doing in controls. And his protege is the gentleman that got selected for the job. So he's taking that on and trying to keep it moving forward. We've also added our mechanical engineer for our design and construction department is taking on a big administration role in that, in the digital control system as well, which is Alan King. I think Alan will talk here in a minute as well. But what we're hoping is that that combination of people, we're going to continue to really delve into the details of what we're doing and make sure we're looking at it from both an engineering aspect and from a technician aspect. Another part of that era, changing era for us, is we're trying to modify our language, and we listed on this slide, but we don't want to call it a direct digital control system anymore, because when we say that, people ask us, what is that? People don't understand it. So we're trying to move to the language of building automation system, because that kind of more clearly paints the picture. And it's also, for us, we've been really focused on our HVAC equipment. When we say DDC, it was almost synonymous with HVAC. And we want to start bringing in lighting and any other components we can into that building automation. So we're trying to change all of our wording and how we say that across campus. One of the things that happened with us when we started small and building by building, and we used a lot of our in-house labor to install the control system. So we, over time, just by moving slow and using a lot of in-house labor, we found ourselves with one system. And as that continued to grow, we went through a lot of efforts to try to maintain a single vendor in all of our buildings. And so far, we've been successful at doing that. But what the challenge we get to now is that about the only way we can do that is to use the preferred brand alternate method to specify our controls vendor, which is automated logic. And what we find is that, you know, we can see how much it costs us, but the vendor also kind of realizes they've got us. So we're facing a real challenge now with trying to make sure that we, you know, balance that need out, that we're not paying additional costs for this vendor. And that's becoming a challenge right now, frankly. The other piece of what we're trying to do and moving forward right now is we want to kind of remove the veil around our DDC system. So it's kind of been, as I said again, our building automation system. We're trying to open it up to the entire campus. So we do have one of the Lucent energy monitors out in one of our buildings, and it's good. It shows you a real basic view of what's happening in that particular building. But what we're trying to do is, and we're really just at the base level of this, we're trying to get our system where anyone on campus can log in and see what's happening, see what's happening in their building, see what's happening in other buildings. And we've got a long way to go with that, but we don't want it to be, right now, a customer calls in and says, my office is hot. That's kind of the end of it for them. They don't know what happens behind the scenes. And what we want to be able to do is share some of that information with them, or let them get in our system and look at what's actually happening or going on. So we're trying to take advantage of that, as Aaron said last night, that whole brain power. If everybody can look and see what we're doing, maybe there's more ideas out there, or something we're missing, or something we're not seeing. And then the last piece of it that we're trying to integrate into our control system is we did a major residence hall renovation, and we've just built a new residence hall we completed about a year ago. And both of those residence halls have individual suite or room load monitoring. We're calling it plug monitoring, but it's actually each room or suite. And we've got that information. We can capture it, we can see it. We haven't fully integrated it yet, but our next step is to put that somehow into our DDC system where we can see that and share that information as well, or be able to let students see it, or other faculty or staff see it. We're trying to get the end user, we're trying to bring them back into the system so that they can help us save our energy as well.
I guess talking about that, I think Anthony Cortese talked a little bit about that communication. And through that data and communication, we can really empower. Any questions out there on building automation systems?
On that load monitoring system on a room-by-room basis, is that a wired system or wireless? And how are you getting the information out of it?
It's a wired system that ultimately goes back into a computer server. So it's basically, right now it's kind of its own independent little control system in a sense. But we ultimately will bring it back from that server. Did I say that correctly? This is my expert on that.
And it picks up the load circuits in the room?
Yes, per suite. But it is looking at it's looking at plug load.
And will it be able to export that data out to, say, a phone app that the students can have to see how much energy consumed again?
Well, that's where we're at right now, is that have got it and we've captured it, but we're not sure what we're gonna do with it or how we're gonna. That's the stage we're at right now, is really trying to develop that and take advantage of having that information.
Yeah, that's what you were just talking about previously, is could we get that to where you incentivize a student to use less energy, and if you can model it out of the room, that's pretty fascinating.
The dorm we renovated is actually individual rooms, so you can literally take it, as this gentleman mentioned, right back to that student. But it's not available for folks to look at right now, beyond us, kind of behind the curtain.
Do you have a deal with the incremental cost was?
On the new residence hall, it was $100,000 out of a $16 million contract.
That was a 300 room, 300 bed residence.
Got a question right here?
Question on the open access, and maybe for other campuses that have similar programs where you are enabling it. Do you get any pushback? The way that some communities are not pushing back on smart metering, saying what energy I use is none of your business, blah, blah, blah.
Well, again, right now, I'm sharing with you guys what kind of our next phase. We just, 2 months ago, we put these new folks in. That's their charge, is to move this forward. So far, we haven't really had that, because there's not a lot of people in the community looking, but we're going to grow that. We want to get it to everybody. So it's kind of our start is to get it to our student environmental center, which you heard some other folks talking about earlier, and then grow it from there to all the way out to where eventually everybody can see it. But we're not there yet. That's just the bleeding edge we're pushing right now.
And I have assurances that the NSA has not tapped into this. But they're working on it. Any other questions out there about building automation systems? Up in the very back row, Jeff Tiller over there.
Are y'all doing any night setbacks in any buildings in the winter? Have success with that, etc.?
We do, and I didn't, in fact, I got nervous up here and skipped over the main part of what I was going to talk about. We do set our buildings back at night. One of the things, the reason I was talking about us having a single vendor is one of the really neat things we've done is a combination of two things. Our campus is about 98% of its electricity to a single point of delivery. And then we've got this single control system across the entire campus. And those two things together, in essence, allow us to operate a bit like a microgrid. So what we're able to do is we look at where our demand charge is going to increase. And we set a target slightly below that, and we monitor what our energy usage is across campus in comparison to where that demand load is. And if we find ourselves approaching that, the control system, what we call phase 1 of demand shedding, goes and takes every thermostat out there and bumps it by 1 degree. So kind of everybody across campus, maybe or maybe not, realizes that their space just got a little hotter. And if that doesn't allow us to avoid that demand ratchet, then we'll bump things a 2nd degree. Then after we've done 2 degrees, then we start going around and looking a little closer at, can we drop this chiller offline for 15 minutes, or can we drop this chiller offline for 15 minutes to try to maintain that load. So that's one of the biggest things that we feel we've done with our control system. It's really, that's probably one of the biggest contributors to that energy savings. Not the only one, and maybe I'm not even sure it's the biggest one, but it is a huge contributing factor. Our next phase now is to really take that a little closer and look a little sharper at that, about specifically what equipment we can shed and not shed. And that's now kind of having this new alliance of an engineer and a technician working together. We can kind of get through those details a little deeper and make that system run a little better. But we are very focused on occupancy schedules as well, as you asked that. So we set everything back at night. The system is a smart system where over time it will learn when it needs to start to bring a building up, so that if we don't have to say start this building at 2 hours early, it's smart enough to figure out, hey, I did that in 1 hour and 30 minutes last time, so it starts in 1 hour and 30 minutes the next time. And it continually adjusts like that. But we are looking. We did just implement, it's been a huge, massive effort over a couple of years, a master calendar that is completely campus-wide, has everything in one place. That allows us to even take a more finer tooth kind of look at that. But that was another big project that had a huge impact coming back.
All right, thank you very much, Randy. I'll finish wrapping up. Trying to keep us on schedule. We're going to miss the last one, so your boss talked too long for you to get up to speed, but that's okay. That's what bosses do on occasion. But think about everything we just heard here, all the different ideas. It's been, to me, it's been amazing. This is an exciting business. We're at an exciting time. We can all sit here and wring our hands. The legislature's gonna, the legislature's gonna cut our budget. The legislature's gonna do this. You know, we gotta get past that. Look downstream, find some great ideas, ignore the noise of the legislature. You gotta work in that direction and work it hard. This is a very exciting, I think a very exciting time. If you're in this business right now and you're not excited, you probably had the wrong career choice. All right, so that's it for this section. Next, I'd like to bring up to the podium Jeff Ramsdale to talk about student posters.